So we're going to solve this first one here, number 7, x squared equals 289 using the square root method. So what we're looking for, is x. We have x squared, so it seems reasonable to undo the square by taking the square root. Let's do that. Let's indicate what we're going to do here. We're going to take the square root of both sides. Now, since we don't know if x is positive or negative, remember what we have to do here is we have to use absolute value. So what I'm going to get here is the absolute value of x equals, now the square root of 289, we happen to know that's 17. Now, what two numbers could you put in here to give you 17? Well, I think what you could put in is x could be, you could put in 17 itself, right? Absolute value of 17 is 17. But you could also put in negative 17, right? The absolute value of negative 17 is 17. So there's our two solutions. 17 and negative 17. Notice too, we could have solved this equation, x squared equals 289, using the zero factor property. What we could do, as we've done before, we notice this is quadratic, so we get everything on one side, 0 on the other. So we get x squared minus 289 equals 0. Don't forget to equal 0. This turns out to factor, don't forget to equal 0, as x and x. Unsquare 289, square root is 17 and 17. We'll make 1 plus, 1 minus. So from here we'll get x equals negative 17 and positive 17. So this method here is using the zero property factory. Okay, did I just say the zero factory property? Well, the zero factor property, whereas the first one up here is the square root method. In this problem, number 9, we're again supposed to use the zero factor property to solve this equation. So it's quadratic, right? We've got a squared term, so I'm going to get everything on one side, 0 on the other. So I'll subtract that 3. This will give us 2b squared minus 5b minus 3 equals 0. Let's factor. Write our parentheses, don't forget the 0. And now 2b squared, we can get that with a 2b and a b. And this 3 here, the 3, we'll use a 3 and a 1. The question is, do we put the 3 here or the 3 here? Well, if I put the 3 here, I'll get a 6, and a 1, I can get a 5. But if I put it here, I'll get a 3, and a 2, I'll get a 5. So this is a little challenging. But look what happens. Let's try this. What if I put the 3 over here, just to see? The 3 and the 1. But then here's what I notice. This 3 out here is negative, so these numbers have to have opposite signs. And if I use opposite signs, I put this sign here with the larger of the two products. This, the way I've written mine, the inner product is 3b. The outer product is 2b. So if I put that minus here and the plus here, then I end up with this. Negative 3b plus 2b, well, negative 3 plus 2 is not negative 5. So this placement of the 3 and 1 does not work. So let's switch them. So we will get, right, our parentheses equals 0. How about 2b and b? This time I'll put the 3 here and the 1 here. And because the 3 is negative, we have opposite signs. And I'll put that middle minus sign with the bigger product. And now my bigger product here is 6 as opposed to 1. So I'm going to put the negative here. So I'll get negative 6 plus 1 is negative 5. And from here I can write my solutions as b is negative 1/2. Right from here, remember, you change the sign of the constant, divide by the coefficient. And then positive 3 from over here. Let's use the square root method to solve number 11. So we've got x squared. We don't want it squared. We want the x. So let's take square roots of each side. I'll indicate what I'm going to do here. Square root of each side. And again, because we don't know what x is, we don't know if x is positive or negative. So we have to use absolute values. So we're going to get the absolute value of x is equal to square root of 169. That's 13. And then what values of x can we put here to get us 13? So now is when we remove the absolute values and get the plus or minus sign. So we get negative 13 positive 13. Or if you like, how about this? Plus or minus 13. And I think the book is probably going to want us to write it like this. Negative 13 and positive 13. There's our two solutions. So we'll apply the square root method again to number 13. So we'll take the square root of each side. I'm going to indicate it. Right? I'm making a good mathematical presentation here by showing how I get from the beginning all the way to the end with a good proof. So square root of x squared, because we don't know if x is positive or negative, we have to use absolute value. Square root of 36, we do know that. That is 6. And now when I remove the absolute value, this is when I get the plus or minus 6. Right? Because what could we put in here? I could put in 6. Absolute value of 6 is 6. I could put in negative 6. Absolute value of negative 6 is 6. So I'm tempted to write it like this, but the book might want us to write it like this. Negative 6, positive 6 as the solution set. Now in number 15, again, we're going to solve this equation. I've got something squared equaling a number. So I got a squared term and a number separated with an equal sign. So let's square root each side. I'll take the square root of m squared equals square root of 10. Square root of m squared is the absolute value of m. Square root of 10, we can't break that down, so we're just going to have to leave that like this. And now when we remove the absolute value signs, this is when we get the plus or minus, not before. So m is equal to plus or minus square root of 10. And again, we may have to write it like this to make the book happy. I'll write it as a solution set. So I think we know what to do with this now. We've got a squared term, an equal, and a constant. So we've got them separated. The squared term and the constant are separated. So let's take square roots. I'll indicate it. Square root of x squared is equal to the square root, and a tall square root sign of 25 over 64. On the left side, the absolute value of x is what we get, right? The square root of x squared. If we don't know that x is positive or negative, we have to write the absolute value of x equals. Now on the right side, that radical sign indicates the positive square root. So how about if we get 5 over 8? Remove the absolute values. This is where we get plus or minus 5 over 8, which is fine, I think. But if we have to write it in terms of a solution set, how about negative 5/8 and positive 5/8?